1, that's 2. So 2 is 2, right? So what about negative 2? That's a little different, but how far do you walk out? You have to turn by what angle? Right, pi, and then it's, so this would be 2e to the I times negative pi, right? Like that. That's another way to write negative 2. All right, we're going too far off. But I was going to say one more thing, though. Yeah, who cares? Let's go. Review. Which one? We don't. Obviously, we're not going to be able to cover this whole thing today, but requests? Number 2. Yeah, we can do 2. Give me just a second. So I don't know how fast you want me to go through this. So
I got through like a good amount of it to like the very last part. I think I was just kind of confused because I wasn't sure if we were supposed to do any of the partial fractions because it's already split.
yeah,
So I kind of just started doing it without it, but I just want to see it.
yeah, that you don't need partial fractions on this. So this problem right here, I say find the sum. Right away, that's a huge hint. Because that means it's either geometric or telescopic, right? Those are the only ones we can find the sum of. So we look at it, it's obviously not geometric, right? For geometric, you need your n to be in the exponent, right? Here, the n is not in the exponent. So what we start off by doing is writing terms out, seeing if we see any canceling or not. So if I start writing things out, starting with n being 1 here, we get 2, right? I'm going to write them in parentheses, 2 over 1 minus 2 over, what is that? 9, okay, plus, now I let n be 2, so I get 2 over 2. I know that that's 1. Oh, wait, no, not 2 over 2. 2 over 4. I'm not going to reduce it. I'm going to leave it as is. And then I'm going to have minus 2 over 16. And then plus 2 over, is it 9? Yeah. Minus 2 over 25. Just tell me if I'm wrong anywhere here. 2 over 16 minus 2 over 36 plus dot, dot, dot. And I'm looking at that, and I actually am seeing that I do get some cancellation here. I see that this negative 2/9 will cancel with this positive 2/9, but I have to go down, right? This is the second term in that parenthesis. It cancels with the first term, but 2 down, right? Two parentheses down. That's my cancellation pattern for the entire thing, right? If I ever go to the second term of something, of a parentheses, it should cancel with the first term 2 down, right? So once you establish the pattern, then what you have to do, or else you will lose significant points on test, is you have to write down S sub n, which is the nth partial sum, which means you're going to add these up, but you're going to stop at n. So I'm going to write 2 over 1, go a little smaller here, 2 over 9, plus 2 over 4 minus 2 over 16, plus 2 over 9 minus 2 over 25, plus, I'm going to do one more, 2 over 16 minus 2 over 36, plus, I need to add that to the train over there. Plus dot, 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 right? And then I like to start at the end. The very last one would be what I get when I plug in n, which is 2 over n squared minus 2 over n plus 2 squared. That's the very last term if I stop at n. The one before that would be this expression, but n minus 1s instead of n's, n minus 1s, right? So that would be 2 over n minus 1 squared. That's what happens. I replace that with n minus 1. Then minus 2 over, now if I replace this with n minus 1, I get n minus 1 plus 2, which is n plus 1. That quantity squared. I'm going to go one more. The reason I'm going one more is because I know my pattern requires 2 parentheses down to see cancellation. Right? Didn't we establish that? Yep. So I'm going to go at least one more parenthesis down. If I wanted to, I could do 2 more down. So what I do now is I replace the n's in here not with n minus 1, but n minus 2, because I've gone 2 backwards. So this is going to be n minus 2 squared minus 2 over, this is now going to become n squared. Like I said, you could do another one if you wanted. You could do another one. But I think that's enough to see the cancellation.
So you mentioned points off, so you definitely have to write that.
You have to write S of n. You have to do it. Yes?
So like, I don't know, like a mechanical way of doing this, like once you identify a telescopic, and you identify like the first part of the stuff's gonna like cancel out like that. The next part's the S of n. So
Yep.
You gotta start from the end. You just kind of show it that way.
Say that very last part.
Then you start from the end term and go back at least to show that you cancel it out.
To show the cancellation, yeah, because you need to see what's going to be left here, right? So I'm going to, once I've got it written down, I start showing my cancellation here, and I start to see what does not go away, right? So the 2 doesn't go away because it's a first term. First terms need to have a second term 2 upstream. There's nothing upstream of this, right? So it stays. This right here is a first term, so it needs a second term 2 upstream. There's nothing upstream. This one's gone, right? Yep. Okay, what about this one? This is gone because it's a second term, right? In this parentheses, it's a second term. The second term requires a first term 2 down. Where's the one that's 2 down from this? Somewhere in the dots, right? Somewhere in here it cancels. Same with this one. Somewhere in the dots it cancels. First term. First terms cancel with seconds 2 upstream, right? Is there upstream from this? Yep. Yes, so this is going to cancel with something in there. All right, this is a second term. Second terms cancel with first terms 2 downstream. There it is, that one right there. That cancels with that. They're gone. This is a first one, right? It cancels with something 2 upstream. So it should cancel with something in here. It's gone. This is a second one. Second ones require first one's 2 down. I don't have 2 down. I stopped, right? This one stays. That one's gone. This one stays, right? These are what remain. So what I have still here is this, this. Everything else has collapsed, telescopic, whatever you want to say, right? It's collapsed down. I'm just in red is all I'm left with. So I actually have a formula for S sub n. It's 2 plus 1/2 minus 2 over n plus 1 squared minus 2 over n plus 2 squared. Right? That's my formula for S sub n. And so this sum, this infinite sum, is the limit as n goes to infinity of this. So now to find the true sum, it's the limit as n goes to infinity of S sub n, which is of that. And as n goes to infinity, this becomes huge, that goes to 0, that goes to 0, and I'm just left with 2 plus 1/2, which is 5/2. What you cannot do, which, like let's say this problem is worth 10 points. If you do this first part right here, and you say, cancel, this stays, that stays, that stays, cancel, 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 and you tell me 5/2, that's minus 7 out of 10. All right, you have to understand that you don't know anything, and I think I even showed you an example in class where that tail piece that gets left doesn't go to 0. Yeah. And so you cannot assume that the tail piece goes to 0. And if you did this, if you just did this and stopped, yes, you would get the right answer, but you got lucky, right? You got lucky, so I'm not going to give you credit for luck.
Telescopics that were divergent.
Yes.
Okay.
that's what I'm saying. I could give you an example on the exam where you get a pattern, things cancel, you get to a final. The ones that I think appeared that I can remember, this was like natural log of something, and they both diverge and go to infinity, which means the telescopic would diverge, but then I couldn't ask you to find the sum because it doesn't sum to anything, right? You know what I mean?
So, is there any meaningful way to check for divergence with this, without doing the telescopic?
No, that's the nature of these. Okay, that was number 2. What else? 3? I'm going to give everyone an opportunity to ask for a question. So if you ask to see one, you have to wait until everyone else has an opportunity. Just, yeah, general question, maybe. We'll see how general it is.
I know you've answered this a couple
What's the meaning of the universe?
but I don't, so on this page, there seems to be like 2 different reviews.
Yeah,
This
there
one
are.
has kind of a comprehensive component along with what we just learned. and
Yep.
this one is what we just learned.
Yep.
So what can we consider out of all of this to be something we would see on the exam?
All of it.
Okay.
I think this is, anything on here is fair.
Okay.
Yeah.
So the final will have comprehensive components from the rest of
Yeah, but not from, I mean, and this doesn't go past chapter 7. I mean, we did start in chapter 5, you know?
which is just what,
Techniques of integration?
yeah.
Yeah, all the techniques, like, you know, I'm not going to ask you a problem where you have to do, like, partial fraction decomposition,
Yeah.
right?
But anything that had to do with like rotating volume.
Yeah. Yep. Now, I would, as you can tell on the review, basically chapter 8 starts on number 4, on the second review,
Yeah.
right? So it's just a little bit from the chapter 7. Okay, number 3, right? Rewriting sigma notation. Rewriting sigma notation, and then determine if it converges or diverges. So I'm kind of killing a few birds with one stone here because you have to be able to translate that into a formula, right, that generates that series. So this goes back to the very beginning of chapter 8 where I gave you a sequence and you came up with a formula. So I'm looking at that, I look at the numerator, I say, hey, those are all odd numbers. 7, 9, 11, 13. So I know how to create odds. I use 2n. But I need to start, I'm going to do this as a sum, right? So I'm going to start my index at 1, just because I could start it anywhere. I'm going to start it at 1. So if I put 2n on top, I'm going to have to do plus what to get start at 7? 5, right? That should generate odd numbers starting at 7. And then on the bottom, I noticed that those are all perfect squares, right? 1 squared, 2 squared, 3 squared, 4 squared, right? So that's n squared. N squared. And now I look at that and I say, does that converge or diverge? So how would you go about determining whether or not that converges or diverges? That's up to you. You have a whole list of tests to run, right? So maybe we try the nth term test. Take the limit as n goes to infinity of this. You get infinity over infinity. Do L'Hopital, you get something like 2 over 2n. That goes to 0. That tells you nothing, right? The nth term test fails. Is it a geometric series? No, it's not geometric. Is it what came after geometric? Telescopic? No, it's not telescopic. We have ratio test, yes?
I have a question. So
Yep.
I guess like regarding the test, do you automatically have to go into order of the test, or you can just like jump to?
Any test you want.
Okay.
Yeah, there's no order on the tests.
Okay.
Yeah.
Could you
Yeah, go ahead.
split this into 2 fractions, take a p-series on both, and then for one of them it diverges, and then it's added to another one that converges? Doesn't that always equal the divergence?
So you can only split series up if they both converge. So when you split them up into 2, they would both have to be convergent series for you to be able to be allowed to split them. Not sure.
Honestly,
Breaking into a sum, breaking it apart is only legal if they both converge. There's, yeah, okay.
no, I was just gonna say, I did the right comparison on this one, and I actually kind of like, I don't know, that's what I would do. I hated it because
So comparison, what do you got?
How do you know just by looking if it's telescopic or not?
I know that I'm never going to have a minus sign in there. So for telescopic, you need like something to cancel, don't you? So you're going to need some negatives in there. And every term that comes out of this is positive. I never get a negative. Good question.
If there's a negative, if there's like a minus sign or a negative, there's a chance.
I might be thinking that way, yeah. But I can tell you right now that on the final, I'm going to say find the sum of this series. That tells you it's either geometric or telescopic. If it doesn't ask you that, then I'm not talking about telescopic anymore.
Oh, okay.
Yeah. All right, so we have a lot of different options here. I heard ratio test, comparison test. You could do integral test. There's a lot of tests you could do. So what would y'all like me to do? Who asked about this? Did you try a test?
No, I couldn't come with the formula at first one.
Okay, so the formula, now we're good with the formula?
Yeah.
Okay. So what do y'all think? What do y'all want to do? Everyone loves the ratio test. Now you love it. Let's see if it works for this. So for the ratio test, what do I need? I need to take the limit as n goes to infinity of the absolute value of this with what plugged in? N plus 1. So 2 times n plus 1 plus 5 over n plus 1 squared, right? And then divide that by that. So flip it. And I actually don't need the absolute value. Remember, this is not a power series, right? We don't have an x in here, so we're not dealing with power series yet. So all we're looking at are n's, which means that as long as all of these are positive, the absolute value doesn't matter. But what I want, remember, what I want is either to know that this is less than 1 or greater than 1, right? Yeah. If it's less than 1, it converges. If it's greater than 1, it diverges. If it's equal to 1, the test fails. I have a feeling it's going to fail, but let's see. Limit n goes to infinity, right? Okay, on top there, we get 2n plus 7 over, let me just go ahead and expand that. N squared plus 2n plus 1, I FOILed that out, times n squared over 2n plus 5. Do y'all agree with that? Yep. Okay, I'm going to do some fun stuff here. I'm going to split this, not into 2, but I'm going to just rearrange it. I'm going to go n squared over n squared plus 2n plus 1 times 2n plus 7 over 2n plus 5. You're allowed to do that. It's multiplication, right? So you could like put this over there and put that over there. Okay, now limit of a product, not derivative. Limit of a product, you can do the limit of each one separately. And if you do that, you're going to get 1. If you do that, you're going to get 1. Because you'll get like infinity over infinity, L'Hopital's rule. You get 1, you get 1. So this all turns out to equal 1, which means the ratio test fails. Okay, so we need another test. I told you the ratio test is like the test, right? For power series, right? It's for what we use it for later. When we're back in this part of chapter 8, the ratio test, we hadn't learned it, and there are ways to do this. So I heard comparison test.
Yeah.
Did you do a direct comparison or the limit comparison?
I did both.
You did both?
Yeah,
Okay. So y'all want to try comparison? Let's try comparison. So that fails. You might want to write that on the end there.
There is something kind of weird about it.
Okay.
You see the counterintuitive.
So let's see. I want to do a comparison. And if you want here, you could say I'm going to do a direct comparison, which means I'm going to try and make that inequality true. There's the other version of comparison, which is the limit comparison. So what do you want to compare this to? Do you want me to tell you what I would compare it to? I would try first 1 over n, or maybe 2 over n. Because this, I mean, the 5 is really insignificant here. When n gets huge, like that plus 5, who cares? So it looks a lot like 2n over n squared. And if you cancel an n, you get 2 over n. So that just seems to me to be a natural thing to try. And that one right there is what? Divergent, because it's harmonic. Why do you know it's harmonic? Constant over linear. Harmonic diverges, right? So this is a divergent series. So what is it that you want to show then? There's an inequality that you have to show now. That these, you're going to compare these two, right, as sequences. You need, Yeah, you need this one that you have, the sum that you're starting with, you need that to be bigger than or equal to this one. If that's true, you're good. Then you've concluded, because if these all add up to be infinite, and these are bigger than those, then that has to add up to be infinite as well. All right, do a little cross multiply here. 2n squared plus 5n is bigger than 2n squared. Yeah, right? That's true. Why? Subtract 2n squared from both sides. You get 5n is greater than or equal to 0. That's true.
Yeah.
We're done.
See, I did 1 over n squared.
You did 1 over, oh, you did 1 over n squared and it wasn't working. Yeah, that's not going to work because that's convergent and this diverges, so you'll never get it to work that way.
That's why I said I thought it was funny, because like, yeah, I didn't figure it out, it was 1 over n or 2 over n in this case. But it's-
Think about what happens when n is big. When n is big, this is basically like 2n. And when that's big, well, that's n squared, right? This constant doesn't have a huge impact on things. Now, another thing you could have done is not the direct comparison. You could have done the limit comparison, right? Do that instead. So how does the limit comparison work? You still do the same thing here, right? You still have to find this, but you don't do the inequality. What do you do?
Oh, you take the limit of.
Take the limit, as n goes to infinity of
It's division.
that 2n plus 5 over n squared over the 2 over n. And what you're hoping for is that this turns out to be positive constant. If this is a positive constant, then whatever this series did, that one will do. Okay, so let's do this limit real quick. Flip it like that, okay? That's 2n squared plus 5n over 2n squared. Limit, n goes to infinity. And that's L'Hopital. Twice, you get what? 1. That does not mean it fails because you're doing the limit comparison test. The limit comparison test says you need a positive constant. 1 is a positive constant. Okay, don't confuse this with the ratio test, right? You all good? I thought someone raised their hand.
Oh, yeah. I was going to say, so for the purpose of that test, does positive infinity qualify?
No.
Okay, good.
Yeah, I think it says it on the formula sheet as well. On the formulas, do you see a limit comparison? It says must be a positive constant. Does it say not infinity? Can I look?
It doesn't say non-infinity, but
Yeah, it doesn't. So infinity is not a positive constant, right? It's an idea of something getting bigger. Yes?
I don't see why you can't split this one up to prove that it diverges. Because like if you have,
I'm saying generally you can't. Okay, so when you have 2n plus 5 over n squared,
like subtraction, then it might not work. Or it's like multiplication. That's
well, how do you want me to split that up though?
it's 2n squared, or 2n over n squared plus 5 over n squared. And then I could split that into 2 separate ones. Because if you were to write out like the first fraction, like out to infinity, and then write out the second fraction out to infinity.
Okay, so hold on. We have a very good point being brought up, but we're going to go off on a tangent. So we have to decide as a class right now whether or not we want to commit time to the review or to this idea. It's up to y'all, but I'm going to tell you right now, you cannot rearrange a series and maintain the sum. You're not free to rearrange things. So I think what you're saying is like if you write this out, you can just rearrange things the way however you want? No?
No.
Okay.
Like that, if you were to write it out, you can prove that like that it is the sum of 2n over n squared plus the sum of 5 over.
You can prove that?
I think so, yeah.
You can prove this, that this is the sum, let's say 2n over n squared plus this sum, 5n, like that?
Yeah.
Okay, so if you write these out, do you agree you're going to get something plus dot, 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 forever? Yes? And then to that, you're forever, sorry. And then plus, this is going to go something plus something, and that's going to go dot, 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 forever. Sorry, forever. And you're saying that if you like rearrange that,
No. I'm
well, to
saying-
make it look like that, you're going to have to. We'll start writing out the terms of this, right? It's not going to be this. The only way it's going to look the same is if you rearrange things.
Yeah. Yeah.
You're not allowed to rearrange things, generally speaking.
Oh, because like the n.
I can show you, that's why I'm saying how far do we want to go on this, because I can show you a sum that adds up to be two different things. I can convince you it's two different things. Look, it'll take me 2 minutes, all right? 2 minutes. I'm going to show you a sum, and we're going to rearrange it two different ways, and we're going to get two different answers, okay? This sum right here.
Probably when we're subtraction or anything negative.
Well, it's more of a general property. This is just easier to show. So this is going to be, if n, start out there, you get this. That goes forever, right?
Yeah.
Okay. So one way I could do it is I could say, all right, don't rearrange anything. What is that? What's that? What's that? So it's a bunch of zeros added together, right? Yes? That's one way I could do it. But I could also tell you, you know what? What's this? What's this? What's this? What's that? What are all those together? 0. What's that? So is it 0 or is it -1? You know what I mean? It depends on how you look at it. And so you have to be real careful with things that diverge. You cannot just start moving things around. This is a divergent series. This diverges. So, okay, I don't want to go any more than that. That's a deeper conversation.
So, going back to the comparison test for a second.
Yeah.
When we talk about comparison, just your recommendation, is it better to try to find something and do the greater than less than for the direct comparison, or should you just go straight for the limit and you like?
I think I don't know. I feel comfortable with both, so I'm not like leaning one way or the other. I usually think about, do I want to do a limit? Am I going to get L'Hopital? You know? If it's polynomials, I think more limit. If it's something without polynomials, I think maybe the inequality. All right, what else? Who's up? Someone else needs to ask. Have you asked for one yet? Is that what you're going to do?
Yeah.
Okay, which one?
So for number 4, I'm wondering if this is like valid. So that's find the radius of convergence and interval convergence.
Yep.
So you always do the ratio test, and what I always like to do is that when I set up limit into infinity, my absolute value, the ratio test, whatever, and then I put that, like all of that has to be less than 1.
Yep.
And then when I start like canceling things out and I have my x value, I just put my absolute value on that and then move that all the way outside of the limit.
Yeah, that's fine.
Okay.
Yep. Do you want me to work it or no?
No.
No? Okay. Does anybody want me to work 4 or no?
I just had a question. Or just ratio test.
Yeah. What was your question on it?
You have to plug in n+1 for the x, right?
Yes. For the x term, yeah, x to the n plus 1, is that what you're saying?
Yes. That's my question.
That's the initial setup of that problem with ratio test for number 3. Right, it's sum 3 to the n, x to the n over n factorial, right? That's it. So you have to replace this n with n plus 1, which means you split it into 2. That's 3 to the n plus 1 right there. This is x to the n plus 1, and then this is n plus 1 factorial. Yeah? And then you flip it, and then it's n factorial 3 to the n, x to the n. Then we get this goes away, that goes away, that goes away, that goes away, and then this becomes n plus 1 times n factorial. The n factorials go away.
Oh, that was my question.
Yeah. And now you have this limit. Limit n goes to infinity of, let's see what's left. I have a 3 on top. That's it, right? N plus 1, and then an x. And that goes to 0. That's the best case that could happen to you. Because this means your radius convergence is infinite, and this means your interval of convergence is negative infinity to infinity, and you're done and you move on. You don't have any test points to consider.
So what if that top part was an n+1?
If this part right here was, let's say n.
Yes.
Let's say it was n. Then when you did this limit, you would get 3, right? So now what you need is the absolute value of 3x must be less than 1 for this to converge. And then you divide by 3. And at this point, you can say the radius of convergence is 1/3. And then here you just drop the absolute value negative 1/3, positive 1/3, and now you have to consider both of these points being plugged in here and see what happens. I love radius of convergence, interval of convergence problems. I told you all this already, because especially the ones that have to test endpoints, because then when you test the endpoints, you're actually showing me that you can do problems like number 3, right? Because on 3, you wind up just having to find if a series converges or diverges, right? The only reason I find 3 valuable on this review is because it forces you to find a formula, right? Which is a skill that we want to be comfortable with as well. All right, yes?
When do we test endpoints and when do we not test endpoints?
When this in here doesn't go to 0 or infinity, when you take this limit, if it goes to 0, you don't have to test endpoints. If it goes to infinity, you don't have to test endpoints. But if it goes to a number, then you have to work out the inequality and then check your endpoints.
Oh, I see what they do.
Can you do 9?
Yeah, I'll do 9. That's fine. Oh, okay. Number 9 has to do with what we just did today.
Yeah, honestly, 9 and 10 are.
9 is exactly what I did first thing today. Find the first 3 terms of the power series 1 over cosine x. You ready? Yes.
Just a question on what you raised just now.
Yeah.
The n on the 3, that wasn't there, right? Just put as an example.
I just threw it as an example. Yeah. Okay, so I want to find the first 3 terms of the power series for 1 over cosine x. So that means I want to rewrite that as 1 over, and now I need the power series for cosine. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. That should be enough for me to get the first 3 terms. Plus dot, dot, dot. This is just old school long division. Inside the box goes what? Yeah, weird, right?
Yeah.
1. Okay. Plus 0, plus 0, plus 0, yeah. And then outside goes 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot, 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 right? That's what 1 divided by cosine x is, right? In terms of series. And now you just start playing the game. What do you multiply 1 by to get 1? 1, okay. So we put 1 here, and then you do 1 times all of that, right? Which is exactly that, just written down here. So 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot, 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 right? Then we come through and subtract or change the signs.
Yeah.
So that becomes minus, plus, minus, plus, minus, who cares? I don't have that one. And now we add down, right? Now I didn't do good on my spacing here. So we need to be careful here. When I add down, I get nothing, right? Here I'm going to have an x squared term. So I'm going to put x squared over 2 factorial